We're going to start with our flip chart first. And so we're actually going to do the last example on the blue tab, the power to a power one. So we're going to keep working with powers to powers, but with a little bit more complicated problems here. So we'll look at this last example here. 3 times x to the third times y to the second times z to the fourth, all to the second power. So remember, that means I need two groups of this expression, 3x to the third, y to the second, z to the fourth. So I'm going to start by writing 3 and then times x, 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 because that's x to the third, y, y, because that's y to the second, and then z to the fourth, z, 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 and z. So that's the first group of it. Because it's to the second power, I need to do this same exact thing again. So I'm going to multiply it by 3, x, 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 y, y, z, 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 and z. Okay, now when I simplify, first of all, I notice I have these coefficients, the 3's. So I treat those like any other numbers that are coefficients and multiply them together. So 3 times 3 is 9, so that's where the 9's coming from. And then I'll go look at my like terms here. So I'm doing x, 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 so that's x to the third, times x, 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 this other x to the third, which would be x to the sixth, because there's 6 of them all together. And then I'm multiplying the y's. So I have y, y, 2 of them, 3, 4 of them. So that would be y to the fourth. And then last but not least, I have z, 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 so z to the fourth times z to the fourth over here, which would be z to the eighth. So that's the final expression there. So this one is a little bit more complicated because we're taking the power of a product here that's being multiplied with lots of different factors. So we're going to jump ahead now to our notes. This will be the only example we're doing in our flip chart. We've already done this part in the previous lesson, so that should be complete for you. So go ahead to your notes packet and we will start with the 10.2 notes part 2. Okay, so we're going to look at how we can apply the product to power properties and coming up with that general rule of what we need to do so we don't have to write it out in expanded form each time. So this is in your Unit 10 notes packet. It's the 10.2 notes day 2. So we're going to fill out this table first. It says find the power of a product. Now a product means multiple factors are multiplied together. It says write each expression in expanded form and exponent form. So for the expression, we have 2x to the third power. Now remember, that means I'm taking 2x and multiplying it 3 times. So I'm going to start by writing 2x times 2x times 2x. So this is 2x to the third because 2x was multiplied by itself 3 times. Okay, now simplest form. First of all, look for the coefficients here. You have 2 times 2 times 2. Be careful, you're multiplying these two together. So if I multiply the first 2, 2 times 2 is 4, times 2 is 8. Okay, so 2 times 2 is 4, times 2 is 8. It is not 6. It's not 2 plus 2 plus 2 is 6. So my coefficient then will start off with an 8. And then I go figure out what I have for the variables. I have x times x times x, and that would be x to the third. Okay, next one. I have 3xy to the fourth. So remember, I'm going to do 3xy 4 times. So I'll start with 3xy times 3xy times 3xy times 3xy. Okay, when I go to write the simplest form version, I need to look at my coefficients here. So I'm multiplying 3 times 3 times 3 times 3. So you'll probably want a calculator here. Careful, it is not 3 times 4. It's 3 times 3 times 3 times 3, which is 81. So for my coefficient, I start with 81. Okay, then I go look at my x's. I have 1, 2, 3, and 4. So I would have x to the fourth. Okay, and then for the y's, I have 1, 2, 3, and 4. So that would be y to the fourth. So 81x to the fourth, y to the fourth would be your simplest expression here. Okay, next one. We have 5y, and we need that 4 times. So I'm going to write 5y times 5y times 5y times 5y. Okay, so start by multiplying your coefficients. So we have 5 times 5 times 5 times 5. So I'll use my calculator. 5 times 5 times 5 times 5 is 625. So that is my coefficient, 625. And then when I simplify the y's, I have y to the 1, 2, 3, 4th power. Okay, next one, I have AB to the 5th. So that means I need to do AB 5 times. So AB times AB times AB times AB times AB. So if I look at my A's, I have 1, 2, 3, 4, 5 of them. So that would be A to the 5th. And then B is the same. So B to the 5th. Next one, 0.5 mn to the 2nd power. So I need to do 0.5 mn, and then I need to do that again because it's to the 2nd power. 0.5 mn. Okay, now when I multiply my coefficients, 0.5 times 0.5, I get 0.25. And then for m's, I have 2 of them, so m to the 2nd. And n's, I have 2 of them as well, so n to the 2nd. Okay, and the last one here for the table. We have 4x squared y, and all of that to the 3rd power. So we have to do 4xx, because that's x squared, y, and then I need to repeat this 2 more times. So I have a total of 3 times 4xx, y, times 4xx, y. Okay, then when I multiply my coefficients, I have 4 times 4 times 4. So 4 times 4 times 4 equals 64. Okay, and then for x's, I have 2, 4, 6 of them. So that's x to the 6th. And for y's, I have 1, 2, 3 of them. So y to the 3rd. So hopefully as we've gone through this, you've started to realize what the rule might be so that we don't always have to write it out in an expanded form. But remember, when in doubt, write it out. So we're going to jump down to fill in the big idea here. When multiplying powers of products, to find the power of a product, so that means multiple terms multiplied together, you are going to distribute the power to each factor and apply the power to a power rules, which is when you multiply the exponents together. And I'll show you how that works. So if I go back and look at this first example, I had 2x to the 3rd power. So I'm going to distribute this 3rd power to both of these factors, the 2 and the x. So 2 to the 3rd is actually 8. That's where the 8 came from. And then I distribute the 3 to the x, which would be x to the 3rd, which is the second part of this expression here. Okay, if I look at my next example, I'm going to distribute the 4 to the 3, to the x, and to the y. So 3 to the 4th is actually 81, so that's where 81 came from. And then I would have x to the 4th, which I do over here, and y to the 4th, which I have in my expression. So I'm just distributing that power to each of the factors. Next one, I'm going to take my power of 4 and distribute it to the 5 and to the y. So 5 to the 4th is 625. That's where 625 came from. And then y to the 4th is in my expression right here. Okay, for AB to the fifth, I take this power of 5, distribute it to the A and to the B, which then I end up with A to the fifth, B to the fifth. So you're just distributing the exponent that is outside of the parentheses. That's when you know that you're taking the power of a product, is when you have parentheses with the power outside of it and multiple terms inside the parentheses. Okay, so now we're going to do a few more examples here. We are not going to keep writing it out in expanded form. We're going to use the rule that we just looked at with distributing the exponent to each factor inside the parentheses. So for example 1, we have 3a to the second all to the third power. So I'm going to take this exponent of 3 and I'm going to distribute to both factors, the 3 and the a squared. So distribute the 3 to the third power, and then a squared to the third power. So 3 to the third power, I'm just going to leave it like that for now, and we'll figure out what that equals in a little bit. And then when I take a to the second to the third power, remember power to a power, I multiply these two exponents. So a to the second to the third would be a to the sixth. Okay, then I can keep simplifying here. 3 to the third, 3 times 3 would be 9, times 3 would be 27, and bring down a to the sixth. Example 2, I have -5, which is in parentheses just to show you that the negative belongs with the 5, n to the third, all to the third. So I'm going to take this exponent of 3 on the outside, distribute it to each factor on the inside. So I would have -5 to the third power, and then I'll distribute the power of 3 to the m. So I would have m to the third, and then n to the third to the third. Remember, I need to take those two exponents, power to a power, and multiply them. So 3 times 3 would be 9. Keep simplifying here. -5 times -5 times -5 is -125. Okay, and then m to the third, n to the ninth. Just be careful and make sure you get each factor inside the parentheses with that power on the outside. Next one, example 3. I have u to the fourth, v to the third, all to the second power. So I'm going to distribute that power of 2 to u to the fourth. So remember, I need to multiply the exponents. 4 times 2 is 8. So I would have u to the eighth, and then v to the third to the second power. So power to a power, multiply my exponents. 3 times 2 would be 6. So v to the sixth. And example 4 here, 5g to the third, p to the seventh, all to the second power. So I'm going to take this 2 on the outside, the exponent of 2, and distribute it to the 5, to the g to the third, to the p to the seventh. So 5 to the second, I'll leave it like that for now. G to the third to the second, so multiply my exponents. 3 times 2 is 6, so I'd have g to the sixth. And then p to the seventh to the second, power to a power, 7 times 2 would be 14, so p to the 14th. Okay, for example 5, first you need to notice inside the parentheses we have some cleaning up to do here. We have to multiply 3x squared times 2x to the fifth. So remember, I multiply my coefficients together, so 3 times 2 is 6. And then when I multiply x to the second times x to the fifth, that's multiplying two powers. And remember, the shortcut then, the rule, is to add the exponents. So x to the second times x to the fifth would be x to the seventh. And I'll keep that in parentheses and bring down the power of 2. Okay, now I'm ready to distribute the power of 2 to each of these factors on the inside. So first, 6 to the second power. Okay, and then I'm going to distribute the exponent of 2 to x to the seventh. So remember, power to a power, multiply those exponents. 7 times 2 would be x to the 14th. I can keep simplifying here. 6 to the second is 6 times 6, which is 36, and then x to the 14th. Example 6. Again, I have some cleaning up to do inside the parentheses. So the 4 cannot be multiplied with any other coefficient here. You could say it's a 1 in front of the m to the 8th, but 4 times 1 is just 4. So then I need to multiply m to the 5th times m to the 8th. When I'm multiplying two powers, remember the rule says I need to add their exponents. So 5 plus 8 is 13. So I have m to the 13th. And I'll keep that in parentheses because now I have to bring down the 3 and distribute the 3 to the 4 and to the m to the 13th. Okay, so I'm going to distribute the 3 exponent of 3 to the 4. So I would have 4 to the 3rd. And then m to the 13th to the 3rd. Remember, power to a power. Multiply the exponents. So 13 times 3 is 39. So I have m to the 39th. Then I need to keep simplifying 4 to the 3rd. So 4 times 4 times 4 is 64. So I'll have 64 m to the 39th. And last one here. The fraction 2/3 x squared all to the 5th power. Do not let 2/3 throw you off. So you're going to distribute this 5 to the 2/3 and to the x to the 2nd. So I need to distribute the 5th power to 2/3, so I'll have 2/3 to the 5th, and we will deal with that part later. And then x to the 2nd to the 5th, power to a power, multiply the exponents, so 2 times 5 would be x to the 10th. Now, when I take care of 2/3 to the 5th, that would be 2/3 times 2/3 times 2/3 times 2/3 times 2/3. Most of you don't want to write it out longhand though, so you can take the exponent of 5 and give it to the numerator and the denominator. So numerator would be 2 to the 5th, denominator then would be 3 to the 5th. Okay, then I need to evaluate what's 2 to the 5th, so 2 times 2 times 2 times 2 times 2 equals 32. Okay, and then 3 to the 5th, 3 times 3 times 3 times 3 times 3 equals 243. And I'll bring down x to the 10th. And that would be your final expression. So it looks kind of messy, but that's just because 2/3 to the 5th power is this complicated fraction here.